Assalamu alaikum. The topic of my presentation is Merkle-demgard construction. Hello, I am Fazle Rabbi Raihan. So, what is Merkle-demgard construction? In cryptography, the Merkle-demgard construction or the Merkle-demgard hash function is a method of building collision-resistant cryptographic hash functions for collision-resistant one-way compression functions. This construction was used in the design of many popular hash algorithms such as MD5, SHA1, and SH2. So, from the early beginning of hash functions in cryptography, the design relied on Merkle-demgard abbreviation is MD construction. The MD construction was discovered by Merkle and Demgard in 1989 independently. Majority of the famous hash functions such as MD4, MD5, SH0, SH1, RIPE-MD160, etc. follows the iterative MD method. Compression function which takes a fixed input length value and output fixed length hash value is the core component of this construction. Here we can see how the Merkle-demgard construction work. First of all, a message is being divided into various blocks, and all these blocks then are hashed one by one. Here the last block is added padding with because of it has to go get the same bit or same size. Here there is a IV function which works with the block and produce the function. So here the first block is being used. Here the x1 is embedded or combined with IV and hashed, and then it is sent to the next function. And in the next function, it has already taken the previous hashed value of x1, and then it also takes the normal value of a block value of x2, and it hashes the value of x2 and combined it with the previous hashing value of x1. Then likewise it goes to the next function. Then the x3 block is being is used here. The x3 is also being hashed and connected with the previous functions, hashed functions. Then likewise it goes to the last function, last block, and in the last block it also adds the previous blocks with it and provides the output here. Okay, how does the Merkle-demgard works? The idea of Merkle-demgard construction is to split the input x into blocks of size t, and the end of the string is filled out with OS if necessary. A final block called the padding block is added, which encodes the original length of the x in binary. So this says the same thing we have discussed here. The last block is added with padding, and the text is divided in t number of blocks. Okay, this is a detailed view of Merkle-demgard construction. The message is first sent here, then the message is divided, the M message is divided into T number of blocks. then it appends padding bits, then it appends length blocks, then it loops through all the blocks and hashes all the blocks, and then produces the output here. Okay, Merkle-demgard construction. This process continues recursively. We have seen here this process is being done recursively. So with the chaining variable being updated under the action of different part of the message until the entire message has been used, the final value of the chaining variable is then output as the hash value corresponding to that message. One of its distinctive feature is that it promotes the collision resistant and pre-image resistant of the compression function to the full hash function. For instance, the collision on the compression function can be detected effectively from a collision on the full hash function. The inclusive of the length at the end of the message is important for this function, and is also important for the predictive number of attacks, including the long message attack. The conclusion. Merkle-demgard construction proves that the security of hash functions relies on the security of the compression function. Thus, in order to build a collision-resistant hash function, it is sufficient to design a collision-resistant compression function. Recent results, however, highlight some instinctive limitation of this MD approach. This includes being vulnerable to multiple attacks, multi-collision attacks, long second pre-images attacks, and herding attacks. Figure 4 shows the detail of this MD compression. Here we have already seen the detail figure 4, where this figure is being shown. So this is all. This construction is very powerful at its time. It was a revolutionary invention, and thank you for your patience for patiently viewing this video. Thank you.